Stem cells are super cool. They are these special cells in the body that can make copies of themselves and turn into other tissue. They will make a copy of themselves and those are called daughter cells. And then they can also become any type of tissue in the body. So they are a major part of the body's repair system. And what they do is they replace worn out, damaged tissue throughout life. And they can basically supply any type of tissue in the body. So these cells first started on their own. And after about 3 billion years, then we saw multicellularity. So cells came together and started to work together. So they would share communication signals back and forth to each other. And over a 200 million year period, the sophistication of that fleet became more robust. So not only were they just aggregating and sharing resources, but now you saw the beginning of cellular specialization. So instead of every cell doing the exact same thing, the cells collectively made decisions to say, all right, you do this function, I'm going to do this function. So this cell became this type of tissue and this cell became this type of tissue. And that each time there was a major advancement like that, it enabled the organism to procure resources in its environment more efficiently than its competitors, and that outlive its competitors that couldn't do those features. And so once we saw cellular specialization, that's when we saw had the need for a renewable pool of undifferentiated cells. Right? Undifferentiated mean they haven't turned into tissue. And so that those cells could replace the specialized cells that had died off. And so, evolution basically created stem cells as a tool to manage complexity of living systems. And, we're the beneficiary of that. So that's the origin of where they came from. And then, another important way to think about them is they're not all the same. They're defined by something called potency. Potency describes what they can basically become in the human body. And you've got 5 different categories of potency. So pluripotent or totipotent, these can form any cell in the body. So a zygote can form any single cell in the human body. Then you have further down that potency list, you have what's called multipotent, oligopotent, or unipotent. And these cells can only become certain types within certain lineages. So an example, a fairly common one, and your listeners might have even heard this before, but hematopoietic stem cells. These are stem cells that come from your bone marrow. But they can only generate a few types of cells in the body. They can't make neurons, they don't make muscle, but they do make blood and they make your immune cells. And so you can see you have different types of stem cells, all of which can self-renew and differentiate, but some types can make everything, and on the other end of that spectrum, some types can only make one thing. So that's important, because when you talk about stem cells, the idea that you could take out, bone marrow and have it make anything in the body, you see now that's not true. That's not true.